In our series of videos on diagnosing engine problems, this video is going to focus primarily on the first phase, the suck phase of the combustion process. We're going to look in depth at the error codes that are related to things that might indicate there is a problem with this aspect of the engine combustion cycle and help you to get to the bottom of it as quickly as possible. When we're accelerating, the car needs more air. It's got to match air and fuel to produce power. If we want more power, we logically need more air and more fuel. That really is a critical part of the intake phase of the engine. Now, things to check would include the air filter. If the air filter is clogged, the engine is just not going to be able to breathe in sufficient air. It may be fine at lower RPM levels, but you start to hit the limits as the RPM increases, and a clogged fuel filter is a classic contributing factor to a loss of power when we're accelerating. The air filter should typically be replaced every 15 to 30,000 miles. It probably depends on where we live in the world, what the pollution levels and the dust particle levels are like. But for most drivers, that is a good ballpark, and most manufacturers set the replacement at about 30 to 40,000 miles. I would shorten that a little bit just to be on the safe side, particularly if we notice a problem when we're accelerating, and changing an air filter is relatively easy to do. If the engine can't get enough air, the fuel mixture is going to be much greater than it should be, and this is a condition we would refer to as running rich. And when we've plugged in the OBD2 port reader, we're probably going to get error codes. P0172 and P0175 are typical error codes that would point to this situation where the fuel is too rich due to a lack of air going into the engine. But those codes do not confirm a blocked filter. It could be the mass airflow sensor or even a faulty injector producing the same effects, but at least we now know where to start looking. The MAF, the mass airflow sensor, sits between the air filter and the engine. It monitors the amount of air and helps the car determine how much oxygen it's got to play with in order to supply sufficient fuel. If that airflow sensor has degraded, if it's become dirty or soiled, it's going to give the wrong readings and the car is going to mess up the calculations, and that's going to manifest itself under acceleration or under load. The fix is often just using a straightforward MAF cleaning spray or cleaning solution. Make sure it is approved for the airflow sensor. It is possible to damage these by using the incorrect fluids which leave a residue on, effectively blocking it and causing all sorts of measurement problems. Relevant codes we should be looking out on our code reader for are the P0100, a MAF circuit malfunction, the P0101, the MAF range or performance problem, and the P0103, the MAF signal too high. But you can also get lean running error codes from a faulty MAF, which would include P0171 and P0174. Most modern cars have a butterfly valve called the throttle valve or the throttle plate, and it controls the amount of air that can enter the engine. Literally by opening or closing this butterfly will determine how much air is getting into the engine. And in modern cars, it's not mechanically controlled by the accelerator, it is electronically controlled. Now, carbon deposits can build up in this area. The positive crankcase ventilation, the exhaust gas recirculation system can all contribute to clogging up of this butterfly valve, and as it starts getting coked up with carbon, it's not opening or closing as effectively, or the airflow is more restricted through it, and that can lead to problems accelerating and causing these flat spots. It's a really good idea just to dismantle the intake, get to the throttle body itself and clean it off. Remove any carbon or oil residue that has built up just to make sure it's working within its design parameters. The throttle body and TPS fault codes that we would typically see that would point to a problem in this area are P0120, P0121, the position sensor and the range or performance, and P0123, the TPS signal is too high. Drive-by-wire setups have an additional set of error codes, the P2100 and P2101, which indicate a fault with the throttle actuator motor, that thing that controls the position of the throttle. And you might see a P2135, which flags that there is a correlation error between these two systems. Something is not working right and it's outside its parameters. Now again, talking about drive-by-wire setups in the modern car, the accelerator pedal is no longer mechanical. It has something to read the accelerator position and to transmit this to the ECU and transmit it to the intake. And it allows the engine to make adjustments. Whether we're in eco mode, for example, it might be more gentle than what our foot is demanding. Now sometimes these sensors start to fail at certain positions. They develop weak spots or flat areas, and that just sends dodgy information to the ECU, and that can lead to a loss of power when accelerating, when the throttle is at these positions where the signal is not as good. And in most modern cars, the ECU will interpret this dodgy signal as a fault, and it'll go into limp mode, reducing the power. The repair is relatively simple. It's generally under about £80 to fix that in most cars. You can often clear these faults just by parking up, switch the engine off, wait 30 seconds or so, switch the engine back on, and that's sometimes enough just to clear the faults and get the car out of limp home mode. And as long as we don't trigger that again, we should be able to drive back home or drive to a garage relatively straightforwardly without problems. We're looking for error codes P2122, P2123, P0127 and P2128, which indicate the pedal position sensor is too high, it's too low, or there's just a problem with the signal the ECU is getting from this component. The P2138 flags there is a problem with what is expected between the throttle position sensors, and that will be enough to trigger a limp home mode on most modern engines. Vacuum loss is also a significant thing. The modern engine requires a vacuum, particularly if it's not turbocharged. You've got to get the air flowing into the engine, and generally the engine will be under vacuum for a lot of the intake cycle. Now if there's a crack in a hose, a split somewhere, a seal is not seated correctly, that can lead to a loss of this vacuum, and that can result in a loss of power. It's just not able to suck in sufficient air in that part of the phase. You'll often get a high-pitched hiss when this happens, and you can hear that under the bonnet. Get someone to accelerate gently, and if you hear this hiss, it could well be a vacuum leak. A smoke test on the intake is the most reliable and easy way to determine the source of this vacuum leak, and this can actually cause a lean system code error. P0171 and P0174 are system lean bank 1 and bank 2 respectively, and a P0507, which would indicate idle control high, can also appear as the ECU struggles to stabilize the idle against this uncontrolled airflow that it's getting. But blocked injectors and a weak fuel pump can also contribute to those error codes, so don't get caught out there. If you've enjoyed the video, please boot the like button. If you're not subscribed to the channel, please do so. We'd hate you to miss out on the great content we've got planned. Thanks for watching. See you in the next videos.